Hey, good morning, good afternoon, everyone. To begin with, thank you very much for joining this exciting talk on journey from trusted open source packaging to secure deployment in production. My name is Hiren Rupani, and I work as Senior Product Marketing Manager in Asia Pacific and Japan at VMware. Open source software is increasingly becoming a very critical element in software supply chain. We hear from a lot of customers about the benefits of increased cost flexibility, cost efficiency, developer productivity. But simultaneously, we are also seeing rise in cyber attacks, and it's not surprising that there are significant concerns regarding security and business risk. So today in this talk, we are going to cover some good insights about how customers are consuming open source today, what are some of the challenges related to open source packaging, and then best practices in deploying open source into production. I will be joined by my colleague Pradeep Loganathan, who is a senior technologist in Asia Pacific Japan at VMware. Before we begin, a quick housekeeping instructions. This webinar is being recorded and will be available for on-demand viewing later on. And if you have any questions, you can put your questions in the Q&A. In the last 10 to 15 minutes, we'll take up some of those questions. So with that, let's begin the webinar. So application architectures are changing. We all are familiar with the multi-tier architecture where you have a web layer, databases in the backend, the web servers, and then predominantly many of these applications earlier were getting deployed into the private cloud. But now around us, we are seeing few things happening. The speed of the innovation has changed considerably. In order to stay competitive in the market, companies are expected to change the application on the fly. There are releases where multiple releases happening even on a single day. Agility of the application is expected to be very high. So as the resiliency, because with cloud native application development practices where applications are changing, it is important for all the components of the applications to stay highly available. And therefore, it's not just about the tiers, but it's about multiple tiers, multiple components of the application have to stay agile and highly resilient. And then we are also seeing companies adopting a lot of different open source code bases. There are a lot of services available in the market which are of high value when it comes to, say, databases, messaging services, caching services. There are different services available for logging, monitoring. So in the midst of such innovation, plethora of services, and the inclination of companies to stay highly resilient and innovative, application architectures are truly becoming distributed, where different components are being sourced from different places. They are getting deployed into multiple different clouds. And therefore, what's happening is we are seeing a true distributed application architectures. Much of them is being powered by the open source technologies. So when you have this kind of an architecture, it is important for us to understand that what kind of open source technologies customers are using and what is the practice of open source usage today, what are the challenges. We did one survey. We reached out to our customers. Given the significant vulnerabilities we have seen in both commercial and open source software, we conducted a survey for the companies of all sizes to understand unique concerns and challenges which they have around open source and software supply chain. So we came up with this report. The report is called as State of Software Supply Chain Open Source Edition 2022. This report covers companies in America, EMEA, APJ, all the companies from small to large enterprises. And we reached out to all the devs, sec, and ops persona from executive to practitioner level. And we found some really good insight about what's happening in the state of open space. So let's kind of understand a bit more about it. First thing, we asked our survey participants a question about what kind of benefits they are seeing into open source. And we found out that almost every company has benefited from open source. The top benefits, what we saw were cost efficiency, increased flexibility. The flexibility is important because with open source, you can customize the way you want to. You can package with necessary dependency and you can make it unique for consumption in your own environment, right? They also appreciated community support to an extent. It is easy to access. There is no licensing involved. So it's simply, you get to reach out to the repo and you download the open source package, right? So faster access, and hence it leads to better developer productivity. We also analyzed the results for the small company and they were no different. Open source usage is very high into small companies due to definitely the tighter budgets. Again, we further analyzed what kind of open source is being used today. We have all seen the proliferation of open source software in the industry, and that's one of the main reason because of which it's very difficult to keep updates, security, and skill development when it comes to such wide ranges of open source. You won't believe that there are more than 180,000 open source projects right now across 1400 plus licenses or tech categories. So that's humongous. So in this survey, when we try to analyze what are the key open source technologies customers are using, we found out that databases, caches, runtimes, operating systems, container orchestration are the top categories of open source usage. In small companies, we saw a slightly different trend. We found out that the usage of container orchestration, CI/CD logging, monitoring, was not that high, but there the line of business software like ERP, content management system, WordPress, e-commerce applications were very high in terms of usage. Further, if we expand our horizon a bit more to understand the current landscape of open source and the challenges, I want to share a few stats. There are more than 1 lakh container currently hosted in Docker Hub, across 100 plus million repositories on GitHub, and 89% of the code base is containing open source. So that proves the value of the open source across the companies. But with growing adoption of such open source software, agile software development practices, what we have also seen is that there is a disconnect between developers, security operators, and IT operations team due to distributed usage of open source across different teams. Packaging practices are varying across different teams, and the process to deploy open source is also quite varying across different teams. We did one study with Synopsys on open source security and risk analysis, and we found out that almost 81% of the audited code base of such open source software had security vulnerability, which can be exploited by attackers. So while companies see benefit of open source, but they also see security concerns, and they need to maintain security practices. They need to have they need to have visibility of the key requirements around security for open source deployment into production environment. So just to deep dive further into this area, we asked our survey participants this question about why they haven't gone very strong with open source in production, why they haven't deployed much of the open source in production. And we found out that almost 94% of the companies had a concern of deploying open source into production. They said that when it comes to deploying open source, they are not comfortable because there are lack of processes in their organization to vet the security, to ensure that the deployment is smooth and it is controlled with the security practices, right? They also expressed concern about lack of sufficient support from the community for certain open source category, and they did not have enough trust to put it into production. So while selectively in the pockets companies are using open source, but when it comes to the production, still there are concerns at a broader level. Further, we also try to dig deeper into what are the key security concerns they have. And when we asked this question about specific security concerns, almost 57% of the survey participants said that because there are no guarantees of remediating or patching vulnerabilities on time, they have less confidence of deploying open source in production. Also, they voiced out difficulty uh, for some of the open source where the changes are too frequent that they are not able to patch on time. Patching is also manual. They are not able to keep track of latest updates which are happening, and hence it's becoming really difficult when you have big scale open source deployment across the company. You can't manage and control that kind of deployment with necessary patches and vulnerability fixes. Further, we all know the importance of software packaging. If you want to consume open source software, you can't consume like that, right? Many companies take up software packaging to ensure that they bind the open source software code with the related dependencies. They can adapt it to their requirements and then consume the overall package across various deployments, right? So we found that open source packaging is an important practice, but it's also another area of concern for many companies due to difficulty and time consuming practices, manual processes, and siloed tools. From the survey participants, we found out that almost 95% of the teams are involved in the process of software packaging. So that's literally everybody is doing software packaging, but everybody is following a different approach. Some of the customers are using community package software. Some of them are packaging on their own. Some of them are packaging the versions which are done by Some of them are using the packages with a version which are packaged by some service provider. So the nature of packaging varies. The processes are also manual, and there are a lot of tools which are there, right? So that kind of slows down the overall process of packaging. Now imagine you have got so many open source software. There are a lot of developer teams. You have so much of applications in the company which are using open source, and then if you have to manually package with siloed tooling with different versions of the packaging, it literally becomes really difficult to ensure confidence into the quality of the open source package, right? Packaging challenges are also on the rise. We found out that some of the key challenges are related to tracking vulnerabilities, dependencies, and ensuring security policy. Because when you are packaging, you need to ensure that some of these things are fixed, right? So critical security patches normally takes a lot of time because the process of packaging is very slow, right? So this is another area we found concerns from our customer. So in summary, what we saw is that there are three areas which we need to address. One is how do you ensure automated software packaging practice? How do you ensure availability of trusted open source, which is already validated from security perspective, fixed for vulnerabilities? And how do you ensure that you are able to deploy open source in a secure software supply chain in the production environment, using a secure software supply chain in the production environment? So we studied the best practices from our customers, and this is the essential guidance what we could distill out of number of conversation we had with our customer. The first thing regarding the packaging best practice, what we saw many customers are adopting is customers are keen to evaluate integrated packaging tools. That means those tools which can reduce the complexity by integrating and automating tasks like functional testing, CVE scanning, and then publishing to the repository. So that's number one. For the access to the open source, because there is so much of choice of the open source, with each having its own life cycle and community support, we have seen organizations being benefited from customizable pre-packaged open source from a trusted library or a kind of a catalog which takes care of all the security related vulnerability fixes and everything, and making it available in a secure manner so that they are able to reduce the risk in terms of deploying into production. And then finally, in order to ensure speed and security together in the process of software code creation to production deployment, you've seen organizations simplifying and securing the path to production by applying security best practices with built-in automation. So what they are doing basically is leveraging end-to-end developer platforms that can automate and secure the process of building, testing, and delivering the software to the production across multiple Kubernetes clusters across different clouds. So with that, in order to understand more about how VMware can help in achieving some of these best practices, let's hear it from Pradeep on how you can elevate your state of open source consumption in a secure manner and really pursue the path of trusted open source packaging and secure deployment in production. Pradeep, over to you.
Thanks, Hiren. Hello, everyone. A very good morning, good afternoon, and a good evening, wherever you're joining in from. As Hiren was talking about, monolithic architectures are changing massively. Organizations are moving from monolithic architectures to microservices, and that's a trend that we've been seeing for quite some time across multiple organizations. And these architectures are moving from simple centralized monolithic architectures to much more complex and decentralized architectures. And the primary reason is that monolithic architectures force a standardized, a generally lowest common denominator technology, and regardless of whether it's fit for that particular purpose. Whereas microservices give you the freedom to choose the right technology stack, language, or database for the business requirements that you're programming against, rather than force everyone into a one-size-fits-all solution. Now, this sort of an architecture allows teams to work with the tools and languages that they're more proficient in, comfortable, and that can leverage their expertise. It also leads to higher quality and more efficient development because you're using the right tools to solve the right problems. Now, a lot of these tools, frameworks, and languages are built by the open source community. Developers, platform operators, and many others need to be aware of multiple things when using these open source components, frameworks, and tools. Some of these primarily are whether there are vulnerabilities in third-party libraries, some of which may be due to outdated or unpatched libraries. They also need to be aware of supply chain attacks on these open source components, which may compromise their source code or distribution channels for any of these open source components that they're currently using in their architectures. You also need to be aware of licensing and compliance requirements for these components. since any failure to comply with licensing terms can result in legal and financial repercussions. You also need to be aware of complex dependencies required by some of these open source components. It is very important to regularly audit and update these dependencies. However, the bigger question that I would like to ask as part of this is, while it's very important to use open source components, is it necessary for development teams and should they be spending their time packaging open source applications, as Hiren was talking about earlier, wherein they need to not only package their open source applications, but they need to manually track every single of these components and their dependencies. They need to be aware of their licensing requirements and their dependencies. They need to ensure that all these components are always up to date, they're healthy and patched, and they need to be aware of the latest CVE fixes, where in reality, developers should ideally be focused on their code and be focused on innovation and building better solutions for the business. So that's where VMware's application catalog comes into play. VMware's application catalog aims to enable enterprise developer teams to leverage the benefits offered by the open source ecosystem while empowering the platform engineering teams with optimal control and deep visibility into open source supply chains. VMware's application catalog provides a customizable selection of trusted prepackaged open source application components which are specific to your organization and that are continuously maintained and verifiably tested for use in various production environments. Organizations can then choose to add these application components to their curated catalogs, custom built to spec on different operating system images of their choice, and delivered securely to the organization's private registry. VMware's application catalog is a cloud-based SaaS service that provides a central repository of prepackaged, trusted, and continuously maintained open source components. These components can be deployed to any Kubernetes environment, including VMware Tanzu Kubernetes Grid and Amazon EKS, Azure AKS, Google's GKE. You can also have these packaged as Helm charts or virtual machines too. Now, this VMS application catalog offers a pretty rich library of open source components. It has more than 130 widely used open source application components that are built to spec on top of base operating system images of a customer's choice. These images are not only built to the customer's choice, but they're also continuously tested on various deployment platforms and are build time scanned for vulnerabilities, helping make these components much more secure and production ready. All OSS components available in WAC are continuously maintained through an automated build pipeline, which tracks the upstream open source project for any new upgrades, which triggers an update or a new build process and ensures that all images in the catalog are always up to date and secure. And these upstream, as we're tracking these upstream projects, we can be triggering a build whenever there is a new CVE or there are patches which have been applied as part of a new CVE remediation process. This ensures that any images that you have in your catalog are always up to date and secure. To sort of deep dive into how this works, your customer can choose any open source component upstream. We already have a catalog of a bunch of applications. So the customer can come in and choose whichever open source components that they want to use. This could be open source tools, open source frameworks, and many other components. Once a customer selects these open source components, the customer has a choice on figuring out what format do they want it to be in. It could be a Helm chart, it could be a virtual machine, it could be a container image, it could be built on a specific OS of their choice. Again, it could be Photon, Ubuntu, and multiple other choices. And it could be further configured based on configuration choices available. And you can also add additional agents and tools on top of these base images that we have. And then this goes into a build pipeline, which then creates the necessary image. Once this image is created, it is tested on multiple platforms such as TKG, vSphere, Amazon's EKS, Azure AKS, Google GKE, OpenShift, and many others. And once it's been verified across all these platforms, the image, along with its corresponding metadata, is published into your own private repository. The customer can then use this private repository to build their own custom service catalog, which now contains secure open source components, which the rest of the organization can use. And not just the rest of the organization, but can also be used by your CI/CD pipelines and other pipelines and tools within your organization to deliver a secure experience of using open source tools. And these can be deployed on a choice of platforms. It could be deployed on VMware's own internal toolset, or it could be deployed on AWS, Azure, or any other hypervisor of your choice. This enables a superior self-service experience for developers and platform operators, while at the same time seamlessly enforcing compliance, security, and operational best practices within your organization. Now that we have seen an overview of how you can have a secure extended supply chain, we will jump into a demo of how we would use VMware's application catalog to sort of use open source components in a safe and secure manner and sort of push them into your own service catalog, which is into your own private repository. I'll share my screen and we'll quickly run through this demo. Then I assume you can see my screen.
Yes.
Okay. So this is VMware's application catalog. It's a cloud console that you could use to build new applications. So if I'm a customer and let's assume I want to use, this is where I have the catalog. The catalog, as I already specified, has 130 plus different open source components. However, if you want to build your own specific component based on your own requirements, let's assume over here, I want to create a new component. I can choose custom. Let's assume I want a container image. And let's assume I want it on Photon OS, which is pretty secure, Photon OS 4. I can then, let's assume, say, I need PostgreSQL as an example, since Hiren also specified that database is one of the most commonly used open source components. So I would like to use PostgreSQL version 16. I want a container image and not a Helm chart. So let's say I go over here. Let me pick up. It's available in HA format. Then I go in and I also have created my own enterprise registry. This is my enterprise registry, which I've created on Azure, on Azure Container Repository. So this is my own enterprise registry, and it would be delivered securely into my own enterprise registry. So what we have done right now is to select PostgreSQL, and we want a container image of PostgreSQL built on top of Photon OS and delivered to me securely into my own registry, which has been currently hosted on Azure's Container Repository. I can now specify a request name. So let's say PostgreSQL. And then I can then submit this. And what would happen is that we would run through the whole process of using this open source component, which is PostgreSQL, and build this component as a container image. We would not only do that, we would also scan the image, we would sign the image, and we'll also deliver additional metadata along with this image. It generally takes around 15 to 20 minutes to do this. The platform operator would basically do this ahead of time because most of these stacks are pretty well known within organizations. While we're doing that, this is how it would get delivered into your Azure Container Repository. So this is my Azure Container Repository where I have previously had PostgreSQL delivered into my repository. I've also had ASP.NET Core, RabbitMQ, Cassandra, and a bunch of other components also being packaged and delivered into my own enterprise registry. So if you take a look at PostgreSQL, I have version 16 over here built on top of Photon, but I also have a lot of other metadata, which is what we'll be pretty interested in looking at. So let me jump into, so this is where I would list everything that's available within my Azure repository. So right now, as you saw in the UI, there is Cassandra, RabbitMQ, ASP.NET Core, and PostgreSQL. Now, I'm much more interested in listing all the additional tags that I have for PostgreSQL, since let's assume one of my development teams is interested in PostgreSQL 16. So I can figure out what are all the various metadata tags that I have for PostgreSQL 16. And let's assume I want to ensure that this image was actually delivered, and I want to verify that it was delivered through VMware's application catalog, and I want to ensure that it's a secure image. I can use cosign to verify that this image is the keys of this image matches the public key that VMware's application catalog delivers into a well-known endpoint. So I can use this command to sort of say, has this image been delivered by WAC, and can it be validated? So all images delivered by WAC are signed. The signature is also part of the metadata that we deliver, and every image and a tag is signed by VMware. And you can verify for these signatures to ensure that they are secure and they're delivered from VMware itself. So that's a pretty key critical element of ensuring that your images are delivered from a secure source. The second part, the if you want to do some deep dive into additional metadata that comes along with an image, I can pull in every piece of metadata that comes with this image. I would like you to focus on the fact that we currently don't have any other metadata information over here. But what I can do is I can use this command to pull in all the necessary metadata information that's available along with this particular container image, which is what this command has done. It has pulled down a bunch of critical information about this particular image. One of the primary things I would like to focus on is SPDX, which is the SBOM, which is a software bill of materials that's available along with this container image that you requested for within WAC. And this SBOM is available to you as an SPDX format. You can also get Cyclone DX. And over here, this SPDX basically lists every bit of component that's available within this particular container image in SPDX format for the PostgreSQL container image that you had requested. Along with that, you also have vulnerability exchange or VEX, which is again another critical piece of metadata, which allows the publisher to authoritatively state if this particular container image has been impacted by a particular CVE, as an example. Not every CVE present in an image might have an impact on that particular image. So VEX allows upstream components to attest that they're either impacted or not impacted by a particular CVE. And that's something that's available through the VEX metadata that we also publish along with these images. You also get access to scanner information because we also scan these images. So you get a lot of information about the image. So the benefits are you basically have an image which has been securely built, has been tested across multiple platforms. You also get access to a bunch of metadata which indicates the software bill of materials for that particular image that you have requested for. It also indicates these scan logs. It also provides you with test results. It also provides you with vulnerability exchange information and a host of other metadata that is critical for organizations which are primarily under regulatory and compliance requirements. I previously worked in organizations where each of these pieces of information was necessary from a regulatory compliance perspective, and WAC makes it much more easier for organizations to be compliant with these requirements as part of their extended supply chain. Now, how do you make this? Now that we have downloaded PostgreSQL and it's available within our own container registry and it's available for the rest of the organization, it can also be made available to the rest of the organization as a service. And over here, let me make it easier. What I'd done previous to starting this webinar was downloaded a bunch of images. So I've used both Bitnami, which is the open source version of Application Catalog, and VMware's Application Catalog to download container images. So I've downloaded Kafka, MongoDB, RabbitMQ, and Redis from Bitnami, whereas I've also got Postgres, SQL, and MySQL from VMware's Application Catalog. Now, what we've demonstrated right now is that while we have concerns about while using open source is critical to unlock innovation within your organization, and there are concerns about how open source is packaged and how it's made available, VMware's Application Catalog can rectify all those concerns by ensuring that you can build a secure extended supply chain into your organization, which provides a secure manner of consuming these open source components, and not just consuming these open source components, but also enables trust by ensuring that there is additional metadata, which indicates things like software bill of materials, the ability to sign these components, and many other pieces of functionality. Let me go back to the slides. So what have we seen as part of the demo? What you've seen is the fact that you can you can securely source your open source components, and you can package them and deliver them as containers or Helm charts or virtual machines to the rest of the organization. This enables you to standardize usage of open source components across the whole enterprise. And not only that, you can also continuously monitor your upstream, and if the upstream changes to maybe patch a CVE or any upgrades, it automatically triggers a rebuild, which would then be again tested across multiple environments, and you would again have access to those test results, and it would be constantly pushed to your registry. This ensures that you use the latest components and use most secure versions of these OSS components. The other one is the fact that you have access to a huge amount of metadata along with these components. You have access to software bill of material, and you have access to VEX information, and all of these metadata that is available along with these components enables you to gain deep visibility into the software supply chain across your usage of your whole open source components. And all of these are automatically validated across all applications and across multiple supported platforms such as AKS, GKE, TKG, EKS, and many others. And this ensures that there is strong reliability in multi-cloud environments. So rather than organizations having to be concerned about how do we package software, or how do we ensure that there is reliable and standardized usage of open source components in a safe and secure manner across the organization, VMware's application catalog aims to solve that problem by ensuring that you have standardized access to open source components, which have been tested across multiple environments and multiple platforms, and which also are packaged in standardized formats along with multiple pieces of metadata. Right. We'll now look at now that you have access to these open source components, and we also saw how it can be utilized across the organization. We'll look at the next step in terms of making sure that these open source components are securely used by the rest of your organization, which is primarily application developers. And that's where VMware's Tanzu Application Platform comes into play. VMware's Tanzu Application Platform provides a rich set of developer tools. It offers developers a paved pathway to production to build and deploy software quickly and securely on any compliant public cloud or on-premises Kubernetes cluster. So what we have done so far is to allow your developers and platform operators secure access to open source components. Now we're looking at how do we ensure that they can securely not only access these components, but also use them and deliver secure software to production. And that's where TAP comes into play. Tanzu Application Platform is an end-to-end integrated platform that enables organizations to build and deploy software more quickly and securely through pre-paved, customizable golden paths to production. And it's available on all public cloud and on-premises Kubernetes clusters. Its primary goal is to enhance developer and platform engineering team experiences, increase enterprise security, streamline software supply chains, and much more. Tanzu Application Platform makes the handoff between developers and operators frictionless, as it requires a simple code commit or a git push. As developers commit code, the software supply chain is triggered automatically, providing a path to production that is secure, scalable, modular, and can run on any Kubernetes environment. TAP incorporates vulnerability scanning tools that automatically check for application container images for known security issues. So sort of deep diving into, we sort of understood what is TAP. TAP is basically an application platform which enables developers and operators to work together well, and it allows organizations to deliver software safely and securely in a much more quicker manner by the use of golden paths to production. We all have an extended supply chain which we have secured, and we know how to securely use open source components. And TAP further amplifies it by ensuring that it incorporates vulnerability scanning tools that can automatically check your application container images for any of these security issues. It ensures that any vulnerabilities that are identified are addressed before deployed to production. TAP offers tools for managing application lifecycle, including continuous integration and continuous delivery tools. These pipelines can be configured to automate security and testing and ensuring that vulnerabilities are addressed early in the development process. It also supports compliance efforts by providing audit logs and reporting capabilities. It helps organizations meet regulatory requirements and demonstrate a commitment to security. TAP also encourages the use of secure configuration management practices and thus reduces the risk of misconfigured application components. Now, we have seen a demo so far wherein we talked about how do you securely package and make these open source components available to the organization. Now we look at a different persona who is a developer, and he would like to use these open source components which you have provided packages for, and how does he or she use these components that has been available within the internal catalog of the organization, and how they would be building a secure application by default. So let's quickly jump into a demo for TAP. I will share my screen. And I think we are good on time.
Okay. Going good.
So this is TAP, and basically what we have in TAP is what we are trying to do in the next half an hour is to build an application. We'll build a Spring Boot application which will use PostgreSQL as a database. It's a microservice which provides an API for managing customer profiles. Before this session, I have already built one instance of it, but I'll also sort of run you through how do you build and deliver it to production. And we will be running through this. This particular component will use the PostgreSQL component that we had recently requested from WAC. We'll show how it will be easily available to the developer to use, and we'll run through how to create a secure path to production for this particular component, right? What we have over here is, if I'm a developer, let me clear my screen. Okay, as a developer, one of the first things that I know is that I am using a Spring Boot Java-based application, but I also need a PostgreSQL database. So as a developer, I would like to see if PostgreSQL is available for me within my platform. And I can see that PostgreSQL has been made available based on the application package that we requested previously through WAC. Now that I have it available, I can claim, or the developer can say, I need an instance of PostgreSQL, which is something that I've done previously over here, wherein the developer has gone ahead and created a PostgreSQL database called customer database over here. I can also create, let's assume for this demo, I can create another PostgreSQL database. Again, the developer would use the services toolkit to create a database. And over here, you can see that we are creating a PostgreSQL database, which was packaged to us previously by WAC. We can figure out if this database has been created. The platform operator has a choice on how large would this database be initially. For example, over here, you can see that the database has been created and it's available for use. Now, let's use this within our application as a persistence layer, and we'll build a Spring Boot Java-based application which will expose, which will allow you to create, read, update, modify, and delete customer records as an example. So the code that I have is over here. So this is a regular Spring Boot application over here. Let me just quickly open it up for you. So this Spring Boot application, I previously built this thing to ensure that we can do it within the necessary time frame. So basically, this Spring Boot application is, as I said, responsible for managing customer information in the PostgreSQL database. And what I've also done as, again, TAP has the ability to, enables developers to quickly get started on building secure applications through the concept of accelerators, wherein developers can come over here and use these accelerators as a means for starting off very quickly on building applications. For example, this is an accelerator which allows you to build Java-based applications, primarily REST-based APIs, and it takes an opinionated approach on how you can build a secure Java Spring Boot application. Now, these accelerators can be created by architects, enterprise architects, solution architects, and others within your own organization based on the standards set up by your organization. And I've basically used an accelerator to create this particular Spring Boot application. And now that I've created the database, I can claim the database within this particular application using a service claim, and that's what I'm doing over here. Let me increase the font size. Okay. So as a developer, all I need to do is to ensure that I use a service claim for the database that I previously created over here. You could see that I have the database over here, which is a PostgreSQL database, and there is no other change required within this particular application to use this database. So right now what we have done is we have created a Spring Boot application, and we are securely using a PostgreSQL database, which was built for our organization through WAC and delivered to us securely through an internal catalog. Now, once I'm ready with this, let's go ahead and now build this application. What I'll do is so let's see what workloads I have. So I have 4 different workloads which are already running on my Kubernetes cluster. I will go ahead and create another one, and I'll just name this particular workload as customer profile 1, which I think I've already done. So this workload will be called customer profile 1. So I'll go ahead and apply this workload so that I can go ahead and create this application and get it to run in production. I need to So I can do this. Yes, I want to create this workload. Okay. While this workload is now, I can figure out how this workload is running, but I'll also show you. And I can also check the status of this workload as it is being created. And this is where the golden path to production comes into play, wherein we'll be using a golden path to production to deploy this application. This application is currently being built and deployed to production, following all the best practices that we have within the organization. Let's now switch over to see what's happening, what generally happens when you deploy an application. So this is the application that I previously built. We use GitOps to pull down the application source code, run the necessary tests, and then over here, we use an image. Again, this image can be built using WAC. And once this image is built, it is scanned. And again, this is where shifting security left is so critical. And this is what enables developers to be aware of all the CVEs that are being introduced as part of maybe packages that are picked up. For example, this is a vulnerability that exists within this particular component that the developers used. The Java Spring Boot application that was built. This particular application has 42 CVEs. I also have a scan policy which allows this application to be continued to be built because I'm ignoring everything except for unknown severity. So this particular code base doesn't have any severities which are unknown, but rather it also has high severities. It's up to the organization to figure out what they would want their scan policy to be. So the developer right now is very aware of the fact that the code that he's building has these CVs, and this is where we talk about shifting security left. Once this particular application code has been built, tested, its container image has been built, it's scanned, no one understand all the various CVEs, and this is where we bind with the PostgreSQL database that we created. It also automatically creates API endpoints based on API descriptors available. And this is where we use GitOps to sort of approve or disapprove a merge request. So over here, let me see what's changed. What has changed over here is that a new version of the container image has been built and it's been made available. So if we go over here, I'm just making sure we're good on time. We can see that we get a lot of information in terms of how the build has progressed. We can, and this is where we're getting a lot of information about all the necessary scanning that's happening, the CVs that are being brought out as part of the scans. It automatically builds using cloud native build packs. And we can also check the status of the workload build over here. And we also have used GitOps to ensure that there is an approval necessary to approve the request as it proceeds through the supply chain. And this is supply chain that we're talking about, wherein we're talking about a complete end-to-end secure supply chain where it pulls source code, tests it, builds an image, scans the image, ensures that it satisfies all the organization's scan policies as necessary, adds additional configuration, brings in the necessary service bindings that we have defined, ensures that the necessary API descriptors available, then uses GitOps model to sort of approve this particular deployment across. Over here, I'm using a single environment, and that's the reason why you see only one line over here. However, you can use multiple environments, let's say dev, test, build, production example, and you could ensure that there is an approval path for each of those environments. Now that we have done that, let's look at the application has been built and deployed. We can right now, this is the API endpoint that it delivered, and this API endpoint has the customer profile, and you can look at the fact that it has, I can call the REST API, and I can perform gets and many others. And if I look at where was this particular image built and deployed, This image was built and deployed into the organization's container repository again over here, which is this one. And this is a completely scanned image, which has been verified in terms of the number of CVEs that it has, and the organization is made aware of how many CVEs that it has. And the developers are also very aware right from day one as soon as they start building their application. So this is how you'd use TAP to enforce security and to make sure that security shifts left as early as possible. You could also figure out additional metadata and other information based on your container image. But more critically, what we have done right now is to ensure that your developer has right now consumed an open source component, which in this case is PostgreSQL. He has consumed it in a secure manner with the necessary confirmation that all the metadata necessary to ensure that this particular component is safe, secure, is available. Then he has run through a production pipeline, which is a golden path to production, which again uses these open source components to build this application, and again provides additional metadata and necessary in terms of the CVEs, application scanning, application testing, which provides a huge amount of confidence into how you deliver secure products to your production environment. With that, I'll stop sharing my screen and get back to the slides. Okay, so as part of this demo, what have we seen? Because it's a demo which has been compressed to show a lot of information in a pretty quick amount of time. So what we have is a developer who, through his internal loop, is responsible for building functionality within an application. He's responsible for delivering functionality, containerizing it, and testing that particular functionality. And that's where TAP comes in play with its golden path to production, which enables this to happen. Once a developer has committed code, the platform automatically pulls that code, builds a container image, and this container image is highly safe and secure because it's been approved by a platform engineering team, and they're aware of the various layers within that particular image. And then it's stored in the organization's container registry, and then it's delivered to production by converting it into a single YAML. And in production, you have the ability to manage, monitor, and secure your deliverable. And all of this happens over a single platform wherein your developers, your SREs, your platform operators, all of them have the necessary visibility. And we ensure that this visibility is surfaced up as early as possible within the development lifecycle by shifting security left and allowing control through the concept of policies, wherein an organization can define policies in terms of security policies and many others to ensure that your compliance and regulatory requirements are met through this whole process. So that's me. That's been a quick demo of how you would use VMware Application Catalog as well as VMware Tanzu Application Platform to deliver open source components safely and securely and package them in a safe, secure manner with necessary metadata, and also ensure that your development teams can consume these open source packages in a safe and secure manner and have the necessary confidence to deliver highly secure code to your production environments in a highly automated way through the use of golden paths to production. Now, this has been a demo which has been compressed to a much shorter time frame, but again, happy to have conversations if you have any more further questions regarding this. In the meanwhile, I'll hand it over to Hiren to talk further about this.
Thank you, Pradeep. I think that was a great demo, and I took a note of one statement you made, that let developer code and stay focused on building innovation through the application code. And I think what we just saw was that while open source is available everywhere, we have got a lot of open source packages. What's more important is that what is the process we are following, to what level of automation we are building in to ensure that we are validating open source, making it available through a repository, and then consume it through an end-to-end dev platform where security is taken care of it, right? So in next summary, we had gone through the essential guidance where we talked about packaging, we talked about a catalog, which is having all the pre-validated, trusted open source software. That's what WAC offers, the VMware Application Catalog. And if you want to experience more about VMware Application Catalog, right? Normally this is a short demo, but then in your free time, I have three suggested actions for you, three resources which I want to share with you. And those are available in the attachment section of this webinar as well. You will find a link which you can save it. So WAC is all about security of open source. That's what we are taking care of it, right? So we need to understand what security best practices we are following in VMware Application Catalog. What are we doing at an OS level? How are we hardening the images? How are we ensuring that the vulnerabilities are taken care of? All those information is available in the security and compliance white paper. This white paper is available in the attachment section. Second, if you want to see the library of the open source components which are already available, while we have got current library, we are keeping on adding new and new stuff. But if you want to experience the current library, what kind of OS options are available, various databases, caches, and softwares available, click on this view open source library, the second attachment. You will see an VMware application catalog UI and see the list of all the open source software which is available. And then if you want to experience slightly technical content, if you want to go in depth about the application catalog, what kind of deployment it follows, how you can consume it, all those stuff is available in VMware Tech Zone, which you can refer as a third link in the attachment section. Further, Pradeep also spoke about Spring Boot 3 application. He actually built a Java application code and he deployed through Tanzu Application Platform. You all are aware that Spring is one of the leading Java application development framework. It's available in open source. One thing which I want to share is that so far we were running Spring 2.7. I mean, Spring 2.7 was our late. Spring Boot 2.7 was our last version. Recently, 2 months back, we shifted and announced a new innovation in the form of Spring Boot 3.0. It's coming with a lot of new capabilities, a lot of new features, and it's also based on Spring Framework 6. So with the shift from 2.x to now 3, what has happened that we have announced the open source support of all the 2.x version to be ending in November next month. So while from an open source perspective, you will not have any support from 2.7 till 2.7, we have also announced an offering which is called VMware Spring Runtime, which is offering commercial support for all 2.7 versions, Spring 2.7. So if you are on an older version of Spring Boot, say 2.5, you have to upgrade to 2.7 and continue to get the commercial support through VMware Spring Runtime. So that's one thing you should take a note of. Second, any application development can't scale with the best practices if you don't have right kind of team structure, right kind of application development practices. We have VMware Tanzu Lab, which has been instrumental in working with a lot of customers with agile software development practices. They have rich experience of developing various kind of applications, and they bring a lot of capabilities to the software development teams. So in case while you are taking note of Spring, if you want to elevate your software development experience, the skill set of developers, the best practices, and the right kind of dev team structure, you can also engage with VMware Tanzu Labs team. And then finally, while Spring Boot 3.x is available, you can do a DIY approach. You can download and run it, configure it in your own environment, but it's also available as a service by Microsoft. The service name is Azure and Azure Spring Applications Enterprise Tier. It's a managed Spring Boot service offered by Microsoft on their own infrastructure. And once you have a Spring Boot application ready, you can use that to deploy there. Also, you can deploy it on Tanzu Application Platform. Both of these are available on trial. The Azure Spring application you can consume through your existing Microsoft Azure commitment contracts, consumption contracts. And for Tanzu Application Platform, I'm moving on to my next slide. There is this Jumpstart utility which we have made it available. Now, if you can't see, if you can't feel, you can't get confidence about a platform capability, right? So Pradeep showed a good demo about what all is possible with TAP. How can the devs get started faster with Application Accelerator? And then when you deploy an application, how can you have full visibility of where the application deployment is progressing, how it's passing through various stages of CI/CD, right? So this is this Jumpstart application. It's a React Lancer application that is available to all the customers for trial. It's for non-production environment. So basically what you can do, you can download this package, you can deploy it on your laptop or your environment. Basically from an laptop perspective, just require Docker Engine, but you can deploy it on TKG, AKS, EKS, GKE, whatever clusters, right? So you can download this, you can run there. You can also deploy a sample application. So all those information is available through this Jumpstart URL. You will find the Tanzu Application Jumpstart URL in the attachment section as well. Okay, so that is something which we wanted to share with all of you. We went through the best practices of open source. We went through a lot of insights about open source and the challenges. We went through a lot of stuff around what are the key challenges customers are facing for deploying in production. We also went through some of the security issues which customers are facing. And then we went through two platforms, VMware Application Catalog and Tanzu Application Platform, which are helping customers end-to-end consume open source in a validated, secure format and then deploy it into production without compromising security. Let's take few questions. We have got 5 minutes. I'll just take one question from the Q&A. So Pradeep, there is this one question. Many companies have different development teams, and across the organization, a lot of application development is happening. And then different teams consume different kind of open source software. Now, today we have a library in the form of VMware Application Catalog that's available to customer. But if they don't find any open source software in it, if they want to request a new software, how is it possible? What's the process for that? How can they get an access in a manner that it's secure and validated for consumption?
Thanks for the question. So here we basically have around 130 plus components, open source components in WAC. These are components that are primarily used by very, very widely across many enterprises. And that's the reason why we have prioritized these 130 plus components, which generally satisfy most of these requirements. However, if an organization has a specific open source component that they want to be packaged for their own organization, they can still request for it through the WAC catalog, and this request will then be analyzed by the WAC team, and they would then work with that particular organization to build and package that particular open source component and make it available in a safe and secure manner for that organization. Since it's a SaaS portal, requests can be lodged, and you can work with your VMware team to make sure that that particular package is available for your organization in a safe and secure manner. So that can definitely be done.
Okay. And another quick question. Normally, with Tanzu Application Platform, we talked about CI/CD, right? We talked about security into a pipeline. Now, there are many development teams who are using different open source software, and they may have different kind of tooling practices, tooling chains, right? So, is there any commentary you want to give from when it comes to standardization? How can they have one library, and can they use one library and one golden path to kind of drive their application development and push it to the production?
Sure. So Tanzu Application Platform enables organizations to quickly build golden paths to production. Out of the box, it comes with 4 different supply chains, but organizations can build more supply chains based on their needs, and specific and custom supply chains, again, based on their needs. Tanzu Application Platform is a much more open platform. So for example, we support multiple scanning tools. As an example, organizations can bring their own scanning tools as necessary. But out of the box, we support a bunch of scanning tools as an example, which allow you to scan your container images. We also support signing of your images. We support cosign as an example. But again, an organization can build their own opinions on this particular platform, or they can use the opinions that come right out of the box. We've seen organizations do both. In a lot of cases, organizations tend to use the opinions that come out of the box, but in some cases, organizations do want their own specific tools and packages to be incorporated into this golden path to production. So definitely that's also possible.
Awesome. No, that's great to hear. So I think we are top of the hour. That's what we have on the Q&A. And I want to thank you all for spending your time. I hope this webinar was valuable in your journey to develop cloud native applications, consume open source. I hope it will be useful to you. If you have any further questions, do reach out to your VMware representatives. This webinar will be available for on-demand viewing later on as well. And attachment section will have those 5 links, very important links. If you want to experience VMware Application Catalog and Tanzu Application Platform for future, you can refer to those attachment section. And again, calling out, do take a note of Spring Boot 3.0 is the latest version. There is definitely a migration for many of our customers. If you want to, you can pursue a migration path. You can reach out to VMware Rep for getting those advice from Spring community or VMware Spring representatives. And if you still want to continue with 2.x version, 2.7 is the latest version you have to upgrade. And from there on, you can subscribe to VMware Spring Runtime to get the commercial support, which is available till February 2025. So with that, I would like to again thank you all for sparing your time, and we look forward to have great application development, cloud native application development journey for all of you. Thank you and have a great day ahead.
Thanks, everyone. Thanks, Shirin.